Hello, everybody, and good morning, good afternoon, good evening. Thank you for joining us. And thank you for taking the time. And welcome to Going Meta, episode 4 already. So, time flies. Ontology-based reasoning 101 is the topic for today. Hello, Jesus. How are you doing? And thank you for joining, especially.
Yeah, no, thank you for having me, Alex. No, I'm doing great. Super excited. You say episode 4, and it's pretty impressive. It's been already
Yeah.
4 months. I mean, it's brilliant. No, I'm doing great. I'm really excited about this session today because I think for the first time we're really going meta today. So we are.
That's good. That's good.
So yeah, that's the yeah, no, all good. Joining actually, we're saying before in preparation that we're joining from unusual locations, right? Because you're in Stockholm
Yes.
with J Focus, and I'm joining from New York at the Knowledge Graph conference. So yeah, pretty cool that too.
Yeah, definitely. So it's a little bit more traveling is seems to be going back to our lives as it seems, and that's a good thing. So that's definitely good. And yeah, like I said, I'm on. We are at J Focus in Stockholm this week. So anybody watching from the Stockholm area and is wondering, come by our booth at J Focus. We are there, and and you are in New York, so
And
it's
same, yeah.
likewise, I guess. Yeah.
Exactly. So there's a bunch of us here at the Knowledge Graph conference. So yeah, come talk to us. It would be great to meet. So like you say, it's great to be out and meeting people face to face. Starting to feel a little bit like 19. So really,
Yeah.
that's nice.
Yeah, I already have a sore throat from talking all day long, so it's really I'm not used to it anymore apparently. So it's like okay, well,
Yeah, I think we
well
got to
that's good.
get back used to it again. So
Yeah, yeah,
great. I
cool.
guess we can probably get started, right? Because we
We
have
get
a
started.
pretty dense session today, and we'll be writing a lot of code, and yes, and I would like it as usual, for it to be as interactive as possible. So, if of course any questions that you have or joining us that posts it on the chat, don't hesitate to interrupt and let's make this, like I say, as interactive as possible. So
Yeah,
the yeah
totally. That
the
that's
plan. Oh, sorry, go ahead.
the goal. Yeah, no, sorry. I just wanted to reiterate on this. Is really, we have a hands-on session as usual. We show one slide today, where we go a little bit on setting a baseline of it all. But it will be hands-on. And if you have any questions, if anything is unclear, or you would like to get an explanation on some things, type it in the chat, because otherwise we assume it's all clear. I will ask a couple of probably questions, but
Of course, of course.
you are invited to do the same. So yeah. Oh,
Yeah, no, it's true, and some of the topics. I mean, I suspect some of the audience that we have in this series might be familiar with some of the concepts that we'll be talking about. But I'll assume it's all new stuff. So anything that's unclear, do let me know. So yeah, like you were saying, so the plan for today, it's pretty ambitious. So ontology-based reasoning. So let's try to understand what we mean by that, and say my objective, and I'm going to, as usual, do it, explain it by doing. I mean, I will just use one slide. Actually, if you want to go to the next one, Alex. My objective is, for people to leave this session with these 3 ideas. I know that these are terms that are used very often, sometimes in an ambiguous way. So I want to show what these things are. And the first one is semantics, and semantics is all about meaning and its ways of explaining explicitly what our data means, which is something that we often don't take too much care. And we assume that based on context, people will be able to make sense of our data. Uh, the way to make semantics explicit is by using ontologies. So an ontology is a formal way of describing what my data means. Again, all these things, we're going to see them in action in a minute. And then the third one is, once we've described what the data means, we're going to be able to do cool things with that. And that's exactly what I mean by inferencing, is be able to derive, to produce to generate new information based on the description that we've just created, which is the ontology. So that's why we call it, ontology-based. Whatever you describe, whatever we describe in this ontology is going to drive the logic that we use to produce new information. So that's, high level what it is. But like I say, we'll start from the movie database and take it from there. Any questions up till here, Alex? Or shall I take control and go on the browser?
Sounds good. Let's dive in and see where we go and where it takes us, and then I guess we will explore.
So you tell me, can you see my screen?
Yes.
Perfect. So just to start from scratch, I'm going to create a database that I'm going to call going meta 4, session 4, just, any random name. So we create an empty database and we use it. So let's connect to it. And I was saying that we're going to the simplest model, the one that comes with an Neo4j, and that all you have to do, you can get it by clicking here through the Cypher basics, but you can also get it by running play movies. And oh, hang on, you mentioned before that it would be good if I can make these a bit bigger. Is that readable, or is that? Let's see how.
For me, it is readable. Yeah.
Let's see, what happens as we move forward. But if it's not, let me know, and I'll try to fix it. So yeah, like I say, if you type play movies, we get a guide that takes us through the process of creating the movie database and querying it. All I want is for it to be created. So I'm going to run this fragment of Cypher, and this is going to put in my graph some nodes and relationships. To explore it, I'm going to show just a tiny bit of Cypher, but I'm also going to jump to Bloom, who should be running here. Fantastic. I'm going to reload my instance so I can connect to the newly created database. And we should have the going meta. Fantastic. I'm going to create a new perspective that can be generated from my data. At the moment, just movies and persons. So that's what's in my database. And I said, well, let's, in case you're not familiar with it, although it's pretty straightforward, what kind of data do we have in this data set? So we have information about people. So we can say in Bloom, which, as you know, does not take a Cypher as input, but more kind of a natural language approach to data exploration. So it would say something, I'm looking for a person named in Eastwood, for example. As you can see, it's mapping, because it's schema aware, it's model aware. It's mapping it to the fact that there's a type of node called person with name, and I'm going to say, tell me the movies were acted. And there's a relationship called acted in. That's what I'm looking for. And if I run this query, we get a node representing Clint Eastwood connected to the only movie in the database where he was an actor. We have more information. And we can see that actually Clint Eastwood also directs. We have probably the hierarchical layout, which is not the one I want here. But we see that Clint Eastwood acted and directed this movie. But just to show how the graph expands, so we see that there's other actors and individuals involved in that movie, and we can see how them are also involved in all the movies. So if I expand Gene Hackman, I see that he participated in other movies and so on and so forth. So pretty simple model, right? So just persons and movies, and their persons are connected to movies, either because they were actors, acted in, or because they directed the movie, directed. I think there's some additional ones, like there's critics that review movies, but the model is pretty simple. That's all that we have. So let's get back to the browser. So what if I ask you, give me a list of all the directors, right? So well, it was a pretty straightforward query. A director is someone who directs a movie, right? So if I had to express that in Cypher, I would say, well, that's probably going to be a person that I'm going to label as there. Person that's connected to a movie, to a directorship, right? So if I return these directors, in particular the name, I can even do a distinct that produces a list of all the directors in my database. We have 28. Well, it's not very exciting, but that's where we start. So my question here, where are the semantics of this question? Someone is a director. Well, the semantics are encoded in that query. So because I'm a human and I understand the word person, I understand the word, I say, well, a director is someone that's connected to a movie through a directed relationship. But that's not described anywhere. So no one took the trouble of going and saying, let's define what a director is. A director is someone who directs a movie. No, that didn't happen. I wrote it, and I can produce a list of directors. That's pretty straightforward. I mean, it would be different if the database was written in Hebrew or in Korean. I might not be, find it as easy, right, to make sense of it. But let's assume that that's one possible way of encoding the semantics of something, and I can use that to enrich my database, right? So I can say, for example, okay, I can annotate my nodes. So I can say these individuals, these persons that have directed a movie, I'm going to tag them as director. So this is a way of inference in a way. So I'm deriving from the fact that someone person and is connected to a movie through a direct relationship, that person is a director. And I can materialize that in my graph. And I can say, run this, and that will update 28 nodes. Not surprising, because we had 28 directors. And now we see that we have an additional tag. And I can say, give me all the directors. And now it's explicit. Now I have individuals marked as directors. I mean, that's step one, let's say. I mean, of course, that has limitations, right? The fact that this has to be, of course, updated, and every time new individuals are added, and some more. I mean, it's kind of okayish, but it's sort of a black box approach. I mean, I have the meaning of my data is encoded in me, a developer, understanding what the data means and being able to write this kind of logic, right? Does that make sense so far, Alex?
Yeah.
Good.
Makes
So
sense.
that's I mean, like I say, that has some limitations because this is more, it's kind of an ad hoc logic. So if I want to do something similar for actors, I will have to write a similar expression to this one and say, well, when someone is a person and acts in a movie, then I tag it as an actor. And the same with the critic, if someone reviews a movie and so on and so forth. So okay, it's one approach, but it's not the best, I would say, because what we want to try today is do the following. So instead of having to write specific fragments of code for each bit of inferencing that I want run on my database, what I want is I'm going to describe my data. I'm going to formally describe, and we'll see how we can do that, that a director is someone that directs a movie. And then have some general code, not necessarily something like this Cypher that I've described, but something more generic that reads that definition and applies it to my graph. So that's the plan. And let's see how we can describe our data. But before I do that, let me remove this label because we're going to redo it again. So I'm going to say, let's, if I can type, let's remove dot colon direct. So I'm removing the tags, and the 28 individuals that I have tagged as directors, now they're back to be just persons, which was the way it was originally. So I said, let's try to describe what my data means. And because my world is described in terms of nodes and relations, it kind of makes sense to describe it like that. So here's an idea, right? So I'm going to create a node. Well, let's use merge, as you know. It's like a create, but it will reuse nodes when they exist. And I'm going to create a definition. And I'm going to say there is something that is a category. And I'm adding this underscore to different. It's not needed. I mean, it's just my way of saying what I'm doing now is describing a schema. I'm describing what my data means. It's not actual data. It's metadata, if you want. So there's one category of things, which is directors. See what we get from there. There's another category of things, that is movies. Movie. And there's a relationship between them that is called, let's call it, let me write the skeleton. I have a relationship that's called directs. And this relationship, because I'm describing it, connects to things. It has a source and a target, or it has a from and a to. And we can use that terminology. I'm fine with that. I can say a relationship goes from one type of node to another type of node. And I can reuse that if we can call this the from, I call it form, and this is the to. I can say that. What does that sound? So I'm saying, okay, there's two types of nodes: the nodes of type director, the nodes of type movie, and there's a relationship that connects nodes of type director, type movie. What happens if I create that? If I do that, there's a bunch of nodes being created, and we can explore them here. So we can see that now we have additional things. In particular, I have the relationship directs that connects to two things. So it has a from and a to. So that's kind of a description of my model. And I've made it explicit. Actually, there are nodes that don't represent data. They represent what the data looks like. So what can I do with that? So, well, I can say, well, is there any instance of things? I mean, because I can say the semantics, the meaning of that could be that any two things that are connected through a direct relationship means that one thing is director and the other one is a movie. That's exactly what we were saying before, except that now we're making it explicit. I'm saying whenever we find a direct relationship, that means, oh, I've called it directs, and I should have called it directed. We can redo that in a minute, because otherwise it's not going to match our model. Let's redo that briefly. So if I can. I can remove the relationship, and I can recreate it with directed. That's the good thing with the merges, because it's not going to recreate it. We have again the relationship. Now it looks probably better. We have directed, and it connects directed to a movie. Okay, so now, because I have a definition, write some code that uses this definition and matches it to our data. What would that look like? Okay, my code would need to.
Jesus, maybe just so that I understand. So
Sure.
this is basically what you did is create like a schema with nodes
Correct.
that have even for a node you have created for a relationship created a node. So to set it up in a way that every point of data is represented in this schema, whereas in the traditional, when you use the graph visualization as a schema, you would get obviously a relationship would only be a relationship and
Exactly.
not a node.
So that's exactly right. So what we're doing is we're saying there are two types of things in my model. One is relationships, and the other one is categories. I didn't call it nodes. I didn't call it labels. I call it category, just to say that the terminology is really irrelevant in this case. And that's how they relate. So this is, in a way, that's my way of representing the meaning of my data. I'm not saying that's the only one, but that's one way.
Mm-hmm.
And you're right. So the exists in the data would not be as an intermediate node, but as a relationship. That's correct. But because I want to describe my graph, I've decided to go with this approach. But
Okay.
bear with me on that, because what I'm going to do now is show, because the whole point of these is not just being descriptive and say, well, there's a direct relationship that connects. And I see that I made another mistake, because this from should go in the other direction. I'm really making loads of those today. Let me fix that. You see how this goes from director and it should be from and to coming out of the relationship. Let me delete that. I can delete the relationship again and recreate that, but this time out because I didn't specify.
Yeah, I just wanted to say, I think you didn't even.
Because I didn't, yeah, it takes a random one. But in this case, again, this is my model. This is my way of describing that the directed relationship goes from a node to another type of node, and that's how I'm specifying it. So that's the model that I have. So if I rerun that again, we have directed, and hopefully third time lucky. There we go. So we have directed from a director to a movie. So why would I want to do something like that, right? Well, I want to do that because now, as it's stored in the graph, and it actually coexists with the data, with Clint Eastwood and the movies, as we saw before, Gene Hackman. So what I can do is query across the two and do pretty cool things. Let's see what it looked like. So I can say, okay, let's find any relationships, and that's interesting. I wasn't expecting any calls. Sorry about that. It's
Well, that's live streaming, by the way.
I hope they don't. That's funny. I'm going to unplug it to avoid problem. That's fun of live streaming. Anyway, so I was going to say, okay, so when we will find relationships in our description, and these relationships will be normally connected to two categories, right? So there will be a category to the left. I don't know why it generates that because it's not needed. So we have the from, and that will be connected through the from relationship. I don't like this backtick notation. I mean, when it's needed, it's fine, but in this case, it's not really. So
guess it thinks you wanna it.
yeah.
Wanna be helpful, but in this case, it's not.
Exactly. So I mean, I don't even need to say that that's a category because I know it. But so we have a let's call it relationship definition, and this connects to a from. This connects to a to. I get rid of the backticks because I don't need them. And when that when that's found, that means there's some definition of my schema. There's a relationship, and my question is, are there any instances of that in my data? Is there any case where something is connected to something else through that type of relationship? So that's what I can do here. So I can say, okay, now let's try to match something connected to something else. And I know I'm using the something because I'm literally going meta, and I'm saying there will be this will be an actual thing connected to, let's call it actual thing too, and they will be connected through a relationship, right? So if that relationship, and I use it with a where, is the type of the relationship is the one described in my definition, right? So if the type of my relationship is the one definition, then that means that this thing to the left, I can put that in a return. I can say the actual thing, let's put it like that, is a whatever from is. I know this is might be a bit involved, but let's get in. And the actual thing too is a let's put a plus here to dot name.
Could you
let's put a
comment from chat? Could you say this is like a hypergraph overlay?
I mean, hypergraph. I mean, let's use the right terminology. Hypergraph normally is a graph where relationships are not do not necessarily connect two nodes. Can connect multiple nodes. So it is an overlay. It's a meta graph, if you want. So that's the idea. So if that's where they're going, yes, it's
I think yes. Yeah.
But not
That's
hypergraph. Hypergraph is a different sort of structure. But yes, so that's exactly it. So what I'm doing, if you see what this query is completely generic. So it's saying, go look at any definition of a relationship. Any definition of a relationship will have a from and a to. It will be connecting two things. Well, then try to find things connected in the graph, things connecting to other things, where the relationship is exactly the one that you found, except in this case where it's directed. If that's the case, then what that means is that the thing to the left will have this type, and the thing to the right will have this type. Does that make sense? Okay, I don't know if that helps. I know it was there before and I removed it, but this, in my definition, is a category, and this is a category, right? So this is the model that I'm exploring. Let's see what that returns. If I made no mistake, and let's go to the code view. What this thing is telling me is that Lana Wachowski is a director, and The Matrix is a movie. So the right part I knew already, but the one to the left is the interesting one, because nowhere this node is described is a person, right? That's all we know about it. But because it's connected to something else, to a movie, through a directed relationship, then I can derive that it is a director. Right? That's what this query does. And again, this does not work for directors or for actors. It works for anything that we describe in our schema description here. Anything that's found there, and for the moment, we only have one definition, that's the relationship directed. It will be mapped to the model, and we will derive these kind of things. Does that make sense?
Yes. Yeah. So
Okay.
so yeah, like you said, I mean, this is the meta graph, or a kind of like it's the you define it. If I understand it correctly, you have defined it ahead of in this first line, and then because you know per definition that this is the one segment is a director and the other segment is an actor, or it could be like whatever else, right? Like you said,
Exactly.
could be like a plant, or it could be a car, or it could be a machine. I mean, depending on
Exactly.
your description or your definition, and
Absolutely.
then you basically find, now going back into our terminology a little bit, maybe you find knowledge inside the graph that is not that's not there explicitly, but
Exactly.
you derive it.
Exactly. And I derive it by describing a formal model. So let's if I rerun that, you see it picks up the 44 record. Maybe there's some duplicates there, but it doesn't matter. It finds all the individuals that can be derived to be a director because they happen to be connected to a movie through the directed relationship. And that's being picked up because the only thing I know, my knowledge about my data, is the one that we were seeing here, that there's something that's called a relationship called directed, and this connects a director to a movie. So whenever we find a directed relationships, the semantics is that the thing to the left is a director, the thing to the right is a movie. And this code that I wrote here is generic enough to pick that up. That's all that's happening. So the consequence of that is, hey, let's extend that. I mean, why not just describe, instead of only directed, let's describe other things, right? And I'm going to be lazy and go back here. And in the same way, I said that when there's a directed relationship, the thing to the left is a director, the thing to the right is a movie. I can say when there's an acted in, the thing to the left is going to be an actor, and the thing to the right is a movie. Okay? Exactly the same definition. So if I run that creates an additional set of nodes. And if I've done things right, we should be able to see them here. Now we have two relationships, right? So, and they converge both on the movie, but they one connects to a director and the other one connects to an actor. And I can keep extending these and adding more explicit semantics and saying, hey, there's other types of relations and that's their meaning. I mean, I've described the meaning of acted in and I've described the meaning of directed. And the thing is, now as I extend this schema definition, exactly the same query that I ran before, and you have it here, I'm going to rerun it. Now it's picking up a lot more things. 216 things, because now it's detecting that things are a director. But if I scroll down, it's also detecting that some things are an actor. You see, exactly the same code. So nowhere is made explicit. Nowhere that this person is an actor, but because it's connected to a movie through the acted in, and in my schema I said anything connected through acted in is an actor. This general purpose code, which you can see it as my inferencing engine, the 101, the most basic thing, is capable of deriving that these actually are. So the same code, all I have to do now is keep expanding my definition and describe more relationships, and this will do more and more things. Does that make sense?
Yes. Yeah.
Perfect.
Yeah, that's cool.
Exactly. That's
really
what I mean.
powerful.
It's entirely data driven. So the same code does different things based on what we define about our data, how we describe our data. And we could go one step beyond. So we can say, hey, instead of just returning a listing here, why don't we do like we did before? Why don't we materialize that? Why don't we tag nodes as being actors or directors? We can do that. So we can do something. We need the help for that. So we need to add an additional label to a node. I need to call the epoch. Oops. I need to be able to type epoch.create.add labels. We have it here. And it takes a node and a collection of labels. So what I'm going to say is, okay, whenever I find something like this, the actual thing to the left, I want to enrich it by tagging it with the type of this from, right? From dot name. And I'll do exactly this. We can say yield node. Let's call it as the froms. And I'll do exactly the same with the bits to the right. And I said that the actual thing number 2, I can derive that it is the 2 category, the name, and I can call that the 2s. And I can return something like, I don't know, a count of the froms plus a count of the 2s. And that is nodes updated, something like that. So if I do exactly the same thing we were doing, but instead of just returning it as the output of my query, I persist that in the graph, assuming I've made no mistake. If I run that, it's updated for 132 nodes. There might be duplicates because sometimes, as we saw, Clint Eastwood would be tagged multiple times, right? Because he was a director and he's also, so there might be duplication there, but I'm doing a simple count. I could have done a count distinct and do a, but anyway, that's not the point. So what's happened now is that by running this generic logic, what's happened is that now we have in our database, we have things that are tagged as directors and things that are tagged, persons that are tagged as directors and other as actors. So now we've made it explicit, right? So as you can see, Aaron Sorkin, he was a person. We knew that, but now he's also tagged. I say tagged, but I mean label. We added an additional label.
Yeah.
So we made it explicit, right? And it's all done by generic code. This code, like I mentioned before, is completely unaware of whether it's updating, like you said before, plants, houses, actors, director, whatever we describe using our categories relationship, this will pick it up and apply it to the graph, assuming there's a match. Does that make sense?
Yeah, that's pretty, but yeah, that's super powerful. I could imagine, because if you
love that, yeah, exactly. That's the whole thing. So that's pretty powerful, and we can do it in. We can use it in many ways. So we can say, I'm doing here we can call it a batch mode. So every time I run this, and let's say I run it at the end of the day, it picks up all the updates and enriches the graph with some additional information. That's one way. But as we know, Neo4j is a transactional database, and we have these super cool event handlers, so triggers, in other words. So I could have that logic added to my database as a trigger, and every time I write to it, it will annotate the data as it's. Let's give it a try. It's a bit kind of ambitious, and we can wrong, but let's try. Yeah, question.
Yeah, the question. Yeah. How could you search for nodes that are actors and directors when those labels are only in the relationships? Is that
The nodes are only in the relationships. Well, that's exactly the way we've implemented the semantics of our, definition, right? So we describe relation, and we're going to see in a minute, and just I'm going to say very, very low, that's exactly the approach that we follow with OWL and RDFS for those of you who are familiar. So we describe things, except that we're going to call them classes. We describe relationships, except that we're going to call them properties. But that's exactly how we describe the world. So these things don't really exist. I mean, they exist as metadata. So I've said that whenever you find a directs relationship, that means that you can derive that the thing to the left is a director and the thing to the right is a movie. So it does not exist. It's my actual inferencing engine, which is a pretty pompous way of calling these 3 lines of code, that goes and reads that.
Sounds good.
Because let me tell you something. What here is creating an ontology. That's exactly what ontology is. An ontology is an explicit model of your domain, of your data. I didn't want to use that expression just to kind of make it as like a how do you call it, like a punchline at the end. But that's exactly what we're doing. So we're creating a formal definition of our domain in a way that our inferencing engine can read it, and whatever you describe here will be applied to your data. So that does not exist. There's no directors in the database. We are adding directors when this runs by tagging certain persons as directors. And the semantics is just as we define it here. Whenever there's a relationship of type directs, you can tag the thing to the left and the thing to the right. It's pretty simple. So I don't know if that answers the question, but that didn't exist. It's the result of applying these semantics, this inference.
Yeah, I hope so. But Gary, if that is not what or is not clear enough, then please.
Okay. So what I was saying is that this inferencing engine, I can create it as a trigger, right? And again, I'm going to use Ep4, which has a pretty cool trigger feature where I can add a trigger. And in order to do that, you have to add a line to your config in EFJ. I won't go into the details, but it's described in the manual of Ep4. You just have to basically enable triggers. And all you have to do with triggers is give them a name, right? So in this case, I'm going to call it, why not? Let's call it micro inferencer, for example. Micro inferencer. And the second parameter is going to be the actual code. What do I want Neo4j to execute every time we write to the database? And I literally paste the code that we've run. So it's totally generic. It's going to find relationships connected to categories, and then it's going to apply that to the graph. I mean, there's not too much point in returning that, but we can still do it. That's okay, because the return is going to be lost. I'm going to just do one little thing. And because this is run, I was mentioning that Neo4j is transactional. This is run in the context of a transaction. So triggers are aware of the elements that the transaction has changed. So I don't want to run this on the whole graph. I want to run it only on the newly added nodes. And the way to do that is very simple. And again, I refer you to the manual, because that goes a little bit beyond the scope of this session. But essentially, one thing I can do is say, I want to make sure that I only do that on the newly added relationship. So these R's, I want them to be in a variable, and this is something that Ep4 makes available to you. Make sure I type it correctly. Created relationships. That's where things can go wrong if I make a mistake. So I've just added a simple additional condition, and I say, don't apply it to the whole graph like we were doing before in a batch mode, but apply only to the to the relationships in this set. And like I say, this set is like the context of the transaction, and this is provided by the event handler that runs this code. So all I'm saying is, don't apply to the whole graph, just to the things that you're changing when you're writing to the graph. So that's it, right? So if I've made no mistakes, this should hopefully create a trigger. And there was a mistake, of course. I must have made a syntax error. It expects, oh yeah, there's a third parameter that I've missed. So we have to indicate whether, the phase of the transaction, where that takes place, and that happens before commit. And without going too much into the details, you have to say when this logic is executed, and now it looks much better. So yeah, this is the logic that will run every time I write to the graph. So yeah, right. So I'm going to do something.
I'm interested. Yeah, that's
good. So let's do something. Yeah. So I'm going to create a person. Who's that going to be, right?
Well, I can guess. Oh no, I didn't guess that one.
Well, there you go. You want to be let's call this Alex. And I'm going to create a node representing me. That's going to be JB. And so I'm going to create two persons, right? And I'm going to say that there's, let's make this a movie. I know it's not a movie, but because we are in this data set, let's say that going meta is a movie. Right? And this movie...
coming to cinemas near you.
Exactly. So I'm going to say that, that, for example, I'm acting in this movie and that you're directing it, right? So I'm acted in going meta, and Alex directed. So how does that sound? I mean, this is pretty straightforward Cypher, right? So we're creating a node that's Alex, and I say it's a person. I'm creating a node that's me. It's another person. I create a movie, which is going meta, and I'm saying, okay, JB, which is this one here, acts in this movie, and Alex directs this movie. Make sense? Yep. So if I create that, and I've made no mistakes as usual, boom, that has created three nodes. And what I would expect from that? Well, because Alex is directing that movie and Jesus is acting in that movie, I would expect my trigger to have tagged Alex as director and Jesus as actor, right?
Without us having it
exactly. We never did that. We said is anything that connects to well, I'm not going to say it again, but you see the definition that we created in our ontology. So if I actually not by clicking there, let me write a query. Actually, I'm going to do it in a pretty cool way. Let's try to find the shortest path.
Oh, yeah.
Between Alex and me. You know how I'm good at reusing code, right? And not retyping it. So this should be closing here, this way, and we can store that in a path. And we are going to return. It's telling us that, that this can go crazy. So we can say don't go more than 3 hops. I mean, I know it's going to be only 2 hops away, but let's limit it to 3. It was just warning us that when you do a completely generic path expression and your graph is large, make sure that you know what you're doing.
That's not a good idea. Yeah, if you have lots of data in your graph, then this is not recommended.
Exactly. So, but what I'm saying here, we'll try to find person nodes connected to each other in any way, but not further away than 3 hops. One being Alex and the other one being Jesus. And if I return that path, well, why are you bigger than me? That's but I think I applied some style before. Yeah, I think it's first of all you're tagged as director, right? So that's the reason why. Because I believe I said directly I'm going to be bigger nodes, but yeah. So you see that this logic has been applied. So Alex is a director, and we never said explicitly tag him as a director. All we did is create an ontology that said things that direct things are directors. And if everything went well, Jesus is tagged as an actor. So that's pretty. I think that's pretty powerful, because, like you say before, I was explicit in the sense that I described the meaning of my relationships, and the meaning being how code should interpret that. How it's kind of a valid way of expressing the semantics of my model, and then we can use that programmatically, and that's one way of doing it, by creating this trigger behavior. And like this, my graph is enriched as I write to it, implementing the logic or the semantics described by our ontology, because that's what we've done. We've created an ontology that contains relationships. I mean, so far it's a simple one, connecting to categories. So let me take a pause here and ask if the whole thing makes sense. So that's what drives my inferencing engine. Yeah, go ahead.
Yeah, let me try to get around this a little bit from another side. So as an application kind of scenario. So if I were an expert on the domain, I could basically define this metagraph for my team and say, okay, this is how we in this use case we see the world, and we have actors and movies, or we have parts or whatever, customers, bits and pieces, whatever, and this is how they are connected, and this is how in all the the systems, these are defined in this way, because this is the logic behind the system we are running.
Exactly it. And not only at the application layer level, because that's great, and that's the starting point. But the ambition of this kind of model of ontologies is to be sometimes, I mean, it can be, like I say, the description of a particular data set, but they can be defined at the department level, at the enterprise level. Some of them are public. And it's a way of saying, I align with this way of describing the world. For example, if I'm in finance, there's an ontology code that describe all the terms and all the concepts, how they relate to each other. What's an account, what's an account holder, what's a loan, and describes all those things and how they relate to each other. So one option would be to go and take that and use it as my definition, but I can create my own, like you say. So it depends, the level of consensus that you want to achieve. I mean, is it going to be for a specific application? But in any case, it's very useful from the point of view that, well, when it goes higher level, or wider in terms of consensus, it's great, because it also introduces an additional element, which is interoperability. I mean, if we all talk the same language, if we all describe the world of movies using the acted-in relationship, not only I will be able to implement logic like this one that runs inferences, but I will also make it easy to exchange data, because if we describe it according to the same model, you understand what my data means, and I can send it over, and we can create an API according to that. So that's the other angle to semantics, the interoperability angle.
Yeah, and sharing data and with knowledge graph is one of the topics we have talked about in this series before. It's like, obviously, if your system is compatible with another system because it uses the same logic or the same rules behind it, then obviously it's very easy to connect two intrinsically different systems together, and then merge them up to have even more by combining them, have more.
And again, you don't leave it to the intuition or to the intelligence of the person who writes the query, because you're providing an explicit description. I mean, I'm saying, an actor is the person that connects to a movie through an acted-in relationship. So I'm making that explicit. You don't even need to, like I said before, if that was written in Hebrew, which I don't speak, by the way, or Korean or whatever, I would be able to run the same logic, because I know that would be correct, because this is a formal definition. It's not based on us humans understanding and making sense because of the contextual information, right? So that's the power of this, is the interoperability. Let's speak the same language, but by making it formal, I can write generic code that does smart things for me. And that's what we hopefully showed today.
That's super cool. We have a couple of questions. Shall we go over them? Gary asks, ultimately, are node labels still needed for queries to find actors and directors?
Are they deleted?
Are
No.
they needed, still needed? Do you still need the node labels?
That's
Ultimately?
a very good point. And actually, for these examples, and I wanted to create something didactic, and I started with this. I'm taking the approach of materializing them and creating them, but and tagging, actually enriching the graph with this additional label. But you're totally right. I mean, maybe in some cases, I want that computed on the fly. I want you to return things that are directors without having to persist it in the graph and putting a tag. So maybe not. I mean, use case. And that's the powerful thing about the semantics. So I've shown if you want, the sometimes called forward chaining approach. I mean, you run all your logic and you persist it in the graph. And at the end, you have a graph that's richer because it has some additional information. In some cases, you want to run that at the query time. So which are the directors in your database? There's none, but I have the logic to get them. So I could have written that instead of as a trigger. I could have written it as a stored procedure that would apply the logic on the fly and return nodes that are directors without necessarily having to tag them. So that's a very good question. And I would there's functionality like that in neo-semantics that uses some of the logic in standard ontology. So yes, very good question, and the answer is no. You may or may not, but for this example, I went with the persisted approach.
Yeah, that makes sense. When Obo asks, when importing RDF ontologies with neo-semantics, are you importing domain range constraints on properties like RO using this _ category graph pattern to enable this kind of materialization?
Perfect. That's perfect cue, because I had an example to show that's the perfect cue to do that. So yeah, what happened in this case? I've created the ontology manually, and using my own terminology, I've called things underscore relationship, underscore category, from, to, which is non-standard. That's not the way we talk in RDFS or in OWL. So what if I've created my ontology with Protege or Smart Logic or whatever your preferred, your taxonomy? So can I import it and do exactly the same? And the answer is yes. So let me show you what that would look like. So, and in order to do that, I had, I think I have it here. Here we go. Actually, I had created it in Web Protege, familiar with this interface. And an ontology can be richer than what we described today. So today we describe how to create properties, right? So we described acted in, but you could, and we could have a wrote, reviewed. I mean, there's plenty of other relationships that you can have in your ontology. And also in classes, you can have hierarchies of classes. You can say that, for example, an actor and a director, the way I've described them, are both subcategories of artist. And we can have an additional type of inference that says when an actor is a subcategory of an artist, anyone who's an actor is also an artist. So this is another type of generic inference we could create. But to keep this short, if you create an ontology with something like Web Protege, you will be able to save it as something like that. This has gone to sleep, but I've saved it here on. Let's go. Hello, wakey. I've saved it in GitHub. Hopefully, it comes back. There you go. So we have something. This is a turtle serialization of that. So this is more the standard way of doing it in OWL in RDFS. So you will have something like.
You want to zoom in a little bit?
Oh yeah, of course. Sorry, let me make that a bit bigger. Is that better? Oh damn it! I didn't want to do that. Is that better?
That's better. Yeah, that's better. Perfect. Thank you.
Even a bit more. So, but it's exactly the same concept. So instead of saying these things a category, I say it's an OWL class, right? And when I described, there's the notion of a subclass of hierarchy, which we didn't show in the way, but it's another construct in an ontology. And we have relationships. We call them object properties in OWL, but it's a relationship. It's a predicate connecting two things, and it goes from, and that's what in OWL RDFS is called domain. It goes from a director to a movie. So you see elements that we've been working with are exactly the same. It's just a different terminology. So we have the same for acted in. We have the same for reviewed, right? So we have all these elements that I can effectively, if I've created, I can import into Neo4j. And the way to do that, actually, I have a little additional step. Well, because in this case I've called things in this way, I have to let Neosemantics know what's my terminology. So before I start doing that, I have to say I need to create a graph configuration, right? And if I run the default one, not set, but init. There we go. So you see that sets a number of things. And if you scroll down, you see that the by default way of calling classes or categories is class. But in my case, I'm going to say that the way I call classes is actually underscore category, we said, right?
Mm-hmm.
So we called it category. What else? I mean, we called relationships. This is the property, the object, the thing. We didn't call them a relationship, which is the default name in Neosemantics. We actually called it underscore relationship. And the same with domain and range, right? So the domain, normally it's called domain, but in our case, we call it from, didn't we? So we said, in my terminology, in my way of calling things, I call it from, and the same with the range. Right? You see, Alex, how domain and range were the equivalent of from and to, right? So all I'm doing here is telling Neosemantics, okay, you will get things in OWL and RDF that are standard, like domain, range, classes, object properties. But when you import them, call them these, because that's the way we talk. That's it's pure terminology. It's just a minor thing that we set. So now, hopefully, if I've done it right, there you go. Now the new values are there, and now I'm in a position to do the import. So I can say antennas. You know that this is going to throw an error, right? But I wait to copy paste. And so I'm going to import an ontology, and I have to pass the URL of where this ontology. I mean, it might be in my case, is a turtle ontology, and I'm going to take it. In this case, from GitHub. Remember to take the raw version of it, not the nice human readable, but this one, and that's the one that we need to pass. And actually, before doing import, I can do a preview. And by doing a preview, it's going to show me what's describing that model. And well, we see things like, well, we have the directed that we saw before, right? Oh, damn it. I have to change something else in my, I have to tell not to use namespaces. So I have to say handle vocabulary URIs. And I'm going to use ignore, because in my case, I'm not using namespaces. So if we rerun these again, now it looks nicer. So we have the review, just like, well, the directs and acts in, like we saw before, with the from and the to. We have the actor, the director. We've defined an additional one saying that someone who reviews a movie is actually a critic. And we've added this hierarchical component saying that both actors and directors are specific subcategories of artists, right? There you go. So that's something that we can express in an ontology. And like I say, I'm not going to go into the details today. But yes, I mean, I could just import that, and that would extend my ontology. I just need to replace the preview with an import. This is going to throw an error because I need to create an index. I will create my index. Boop, boop, boop. Perfect. And if I rerun that, it should import the additional elements. And now we have an extended ontology. And actually, if we can, I mean, I don't know, we can actually, it's a good point. I can show an example, if I've done things right, of this inferencing on the fly. And that's built into Neosemantics. So I can say antennas, inferencing nodes labeled. So I can say, give me all the nodes labeled as artist. how many do we have? We have no artists in our database. We have actors, directors, but we have no artists. All I know is that anyone who's an actor or a director is also an artist, because this is a more generic category. So if I've not made any mistake, that should apply this logic on the fly and return a bunch of nodes that are effectively artists, and they're all, as you can imagine, so this is another way of applying the same concept. So I'm deriving information, except that in this case I'm doing it on the fly. So and we can kind of test it and say where node. So some of them will be directors. So there's 29 directors that have been inferred to also be artists, the 28 that we have, plus Alex, right? Remember, we added manually. Some of them will be actors.
Yep.
Actor, right? So probably 100 and something. But we will probably not find any, which were the others, critics or anything else, because these, it's not what the ontology defines. So again, I hope it was quick, because I'm conscious of time, but I guess that shows how, well, two things. Yes, if you create your ontology with standard tools, standard W3C standards like OWL, RDFS, you still can import it and have the same type of logic in Neo4j. So that's what Neosemantics helps you doing. And then the second, which is how you can run this inferencing. You can use the batch sort of approach that persists and enriches the graph, or the one that's kind of on the fly. I mean, you can derive this information at query time without having to make it persistent in your graph. Hope that kind of made it a bit clear.
Yeah, I think that's very clear. Maybe before we wrap up, one question from Nicola is on how to show the triggers working in a database, because we now showed that you can add triggers. Is there an easy way to see what triggers you have running on your database?
Yeah, absolutely. So I believe, and that's I'm not an APOC expert, but I think APOC has a list of, you see that, right? So you can create, which is the one I use, but I suspect if I do list, it will give me all the ones that are currently active, and we only have my micro inferencer. But that would be the way. So, and essentially a trigger is some logic, some Cypher logic that's run as you write to the database, and you can restrict it, as we did here, to some contextual elements from your transaction, the newly created nodes, the deleted nodes. So you have full control on which part of the elements in the transaction you want to use. So yeah, I mean, that's been pretty meta, but I hope, because let's go back. Maybe I can stop sharing and let's get back to the original slide, Alex, the 1, 2, 3, right? Because that's, I think that's the proof or the pudding, as they say, right? So we want to make, I mean, I hope it's clear now. So the semantics can be either explicit, because we put them in the graph, I mean, in some formal way, or implicit, because they're just not there. And we assume that people will know how to query your data and how to know what is a director, because you could have something richer, right? Here we said something pretty basic. Someone who directs a movie is a director. But you could say, if you're a director and your movie has had an Oscar, then you're a top director. So you could enrich that of the expressivity of your. But the key thing is, are you making it explicit? I mean, are these semantics made explicit in a way that then you can programmatically use them, or is it implicit? So that's the first point, semantics. The second one is ontologies. Ontologies is a way of making that meaning explicit. We've touched on basic parts of it. You can do additional things like, you can say there is a relationship, but this relationship is transitive. So if A connects to B and B to C, then A connects to C. So there's additional bits of meaning that you can put in your data, in your graph, And by putting those bits in there, you can do even more sophisticated reasoning. Keep in mind that this was a 101, so I wanted to show the key elements. So you have the semantics made explicit in the form of an ontology, and then you have some software, some logic, some program, generics, an inferencing engine that goes look at your ontology, looks at your data, and does something clever with it. And here we've enriched the data that was there, but it can be used in some different way. And that's what we did last month when we looked at Shackle. I mean, Shackle is another way of, it's not an ontology, but it's a way of formalizing what your graph should be. And if you tell me that only an actor can be connected to a movie through an acted in, and you have a car, I can tell you, hey, that has the wrong type. I won't change anything, but I will produce a report of the violations. Right. So that's another way of using kind of semantics. So there's many things that should probably start making more sense with what we presented today. But yeah, I'll stop talking because it's been a pretty long session. Any other questions?
No more questions. I think that was super cool, and I was, I didn't know this is possible, and I'm pretty excited about this, and I think this has very cool possibilities and opens up how to work with this all in for me new ways, but definitely hopefully for everybody else it was interesting and enlightening to see this and what can work, and especially now I think with your closing comments almost, I felt like very exciting, because if you define something and say that this is how it's supposed to be, and then you add data and then you get an error back and it tells you, hey, this does not fit the requirements, this is not how we defined this. So then this not only predicts or prevents errors from user side, but it also keeps everybody clear on the
on the meaning. Yeah, exactly. And keep in mind one thing, Alex, which is pretty powerful, is the fact that it's not hard coded. I mean, it's all driven by your ontology. Tomorrow I say that there's a new type of relationship, or that the definition of a director is not just someone who directs a movies, but someone who directs a play as well. Maybe you can keep extending, and just by adding new elements to your ontology, the behavior of your engine will change, and it's purely data driven, and that's entirely dynamic, and it's pretty robust. I mean, you probably want to put limits to that, and we see the value, for example, of taxonomies and hierarchies, like I showed with the artists and the directors, for things like recommendation and semantic search. I mean, my opinion, in this, take it with a pinch of salt, because it's my personal opinion, is that if you go crazy with the semantics that you built in there, it can become, in a real world scenario, it can become more complex than the value it brings. But there are small bits of semantics that can be really, really powerful, and that's what I invite everyone to explore. I mean, there's ontology modeling tools up there. I show you can import the results into Neo, take your data sets and start building cool stuff, and share it with us. I mean, we want to hear from you in the community, and also here, where neo-semantics also falls short, to also keep adding features to make it even more useful.
Yeah. Should we? There's one more question came in. Maybe we touch on that quickly. CodeStrap asked, and maybe this is beyond what we have time for now, but maybe you can at least see if this is something you could answer. Is, have you considered what this could mean for grand stacks, federated GraphQL, and interoperable applications? Is that?
That's, I mean, yeah, that's. I mean, I have to say that I'm not an expert in GraphQL, but I don't know if you can. That's probably a question more for Will, but I don't know if you can bring some standard, definitions. I mean, or use an ontology to create a GraphQL schema of your data. I mean, it sounds like a possibility. I probably, like I say, I'm not an expert on that, so I cannot give you an answer. But definitely bring that to the community, or to Will in particular, and I'm sure he'll be able to help.
Exactly. Yeah. Maybe try CodeStrap. Maybe ask this question again in our Discord server, where we have a GraphQL group that's pretty active and engaging. So maybe that's you can reference this video, which will be on YouTube, obviously, and then maybe that's something to explore. But yeah. I guess that brings us round to the end of today's session. I think that was, for me at least, was very cool, very insightful, and a great journey around to ontologies and metagraphs. So
So now you know what we mean by ontology-driven inferencing. So it's so easy to
yes,
explain, isn't it? Well, anyone who
it's
doesn't get it, just come watch
yeah,
this video, which will be in YouTube, and she'll be no more doubts. But dude,
absolutely. Well then, thank you, Jesus, for your time and for preparing this and guiding us through. It was great. Thank you all for watching. Obviously, as I said, if you are further interested in this topic, obviously subscribe and like this series. But in the meantime, you can always join our community on community.neo4j.com or on our Discord server and get engaged with our team and the wider community there. Until then, I guess we see you next. And the next session is tomorrow with my colleagues Florent, and he will be going into PHP. So if you're interested in that, tune in tomorrow. Other than that, take care, everybody. Stay safe and have a good rest of your day. Thank you.
bye everyone. Thank you.